Alright, we're now looking at 2D.3. I can identify the maximum/minimum amount of a real world situation by completing the square to find the vertex. Okay? So, a hovercraft takes off from a platform. Its height in meters after x seconds is modeled by h of x equals x minus 3 squared plus 108. Sorry. What is the maximum, and what does it mean in context of this problem? Right? So remember, with this vertex form, right, we looked at this in 2A.2. Okay, remember our vertex is the maximum or minimum, and it comes from here, where we change the sign, and here, and that stays the same. So our vertex here is, this is -3, that's going to change to +3, and this 108 is going to stay as positive 108. So that's our vertex from this equation. So what does it mean? Well, after x seconds, right, x is my seconds. So after, instead of saying x seconds, I'm going to say 3 seconds. And then this is my h, right? And that's talking about height. The other word we have to include is this word maximum. After 3 seconds, we're talking about the hovercraft. Reaches a maximum height of 108, not 18, 108 meters. Okay, so after 3 seconds, the hovercraft reaches a maximum height of 108 meters. That's what that means in context of this problem. Okay, that's what that 108 means. All right, let's look at number 2. The height of an airplane at the Chicago Air and Water Show x seconds after its dive is modeled by h of x equals x minus 3 squared plus 2. What is the minimum and what does it mean? So again, our vertex can be a minimum or maximum. So again, we're looking for our vertex. We'll change the sign, so that's 3, 2. So again, this is our x. So after 3 seconds, what are we talking about? We're talking about an airplane. Then, is it a maximum or minimum? It's a minimum. And then we want our y value of 2 kilometers. So after 3 seconds, right, so our x value, the airplane, our object, minimum or maximum, that reaches a minimum, and then our y value. One more of these. Oh, no, this is a different type of problem. The number of bacteria in millions is refrigerated, in a refrigerated food is given by n of t equals t squared plus 2t plus 3, where t is the temperature of food in Celsius. Use the completing the square method to determine the temperature where the population of the bacteria will be a minimum and the corresponding number of bacteria. So, for here, now we're doing what we did, on our last one in V2, where we have to complete the square. So we are given this n of t equals t squared plus 2t plus 3. We're going to focus on just this part. So the first thing we're going to do is subtract that 3 from both sides. And we'll write it to now we have t squared plus 2t plus blank, right, equals, well, 0 minus 3 is negative 3. I'm going to do my completing the square. T squared goes here. So that's t times t. Then we have 2t being split between two boxes. 2t divided by 2 is 1t. So we have 1t here and 1t here. That means on the outside we have t times a positive 1 and t times a positive 1 to get this. And 1 times 1 is 1. Ooh, I forgot my blank. Right, sorry. So here is my number that completes the square. So t squared plus 2t plus 1 and negative 3 plus 1. Then there are two t plus 1s, so that means I have t plus 1 squared, and then negative 3 plus 1 is negative 2. And then we have to get it back to that equals 0, so we're going to add 2. And we have t plus 1 squared plus 2 equals 0. Now that we have it like this, we're going to do the same thing we did in number 1 and 2. I'm going to pull out my vertex. And I get negative 1, right? Change the sign, don't change the sign. So this T is the temperature. So this is at negative 1, this is in degrees Celsius. What are we talking about? Well, we're talking about the number of bacteria and are we talking about a maximum or minimum? We're talking about a minimum. And then our Y value, right? And it's of 2 million. Let's go ahead. Right. So once we do we're kind of putting together what we just did in D2 and then what we just did in our 2 problems above, pulling these things out. All right, let's look at our next example. The number of board feet in a tree is approximated by the model f of d equals d squared minus 4d plus 28, where f is the number of feet and d is the diameter of the log. What is the diameter that will produce the minimum number of board feet? Okay. So, same thing. I'm going to take this equation, okay, and just set it equal to 0. We'll start with moving this 28 to the other side. And then adding in our blanks, right? So we have d squared minus 4d plus blank, right, plus blank. On the side over here, we'll do our lovely completing the square. Well, we know we have d squared, which is d times d. Negative 4d, if I cut that in half, I'm going to have negative 2d and negative 2d. That means on the outside I have minus 2 and minus 2. And negative 2 times negative 2 is positive 4. So this positive 4 is the number that goes in our blank. And our lovely numbers on the outside, it's d minus 2. There's 2 of them. So that's d minus 2 squared equals negative 24. Last step, we're going to add 24 to get this back to 0. So then, right, our vertex, we change the sign on our first number, so we get positive 2, 24 stays positive. So our x value is really d, which is the diameter. At a 2-foot diameter, what is this? And we're talking about the number of board feet and then this is, I believe, a minimum. So reaches a minimum, and then our y value, right, of 24 feet. Okay. All right. Don't worry about number 5 for now. Go ahead and get started working on D3. Oops, sorry. Nope, go away.